are they possible? You would do a sail that has two different materials on it. If you study this from the viewpoint of thermodynamics and equations of motion, turns out at 0 Kelvin in a quantum vacuum, no sail will work if it is rigid and static. Sails need to have moving parts in order to leave a wake and be effective. Here's another idea that I worked on about forward. This is a vibrating mirror Casimir drive that Mark Millis mentioned. So you have a mirror here. It's vibrating in a certain way, asymmetrically, and as a consequence, photons are emitted more from one side than the other. And there's a net radiative force on that mirror as it vibrates. We did a QED calculation, in quite detail, assuming a 1 nanometer amplitude of vibration of 30 megahertz. We basically find a acceleration per unit area about 10 to the minus 20th meters per second squared. Obviously, this is not going to be a prime candidate for the first ship out. There are methods to increase this acceleration by about a factor of 10, putting it in a cavity. But the point of this exercise really is just to demonstrate from our current knowledge of quantum field theory that we can use the vacuum. This process requires energy but no propellant. Obviously, with some improvements, such as a material that could have a higher amplitude of vibration, that might ultimately become practical. Another idea here is a Casimir impulse motor. Here we have two plates, and let's imagine that one of them is illuminated with light. And as they are in equilibrium, the two attractive forces balance. We then imagine turning off this light very, very rapidly. And as it's turned off, the carrier density in this semiconductor will change, and the Casimir force in it will be reduced. There will be a moment before equilibrium is established when you will have a non-equilibrium situation. The force on this place to the right is going to be greater than the force on this plate to the left. And so there'll be a net impulse to the right. And then when equilibrium is reestablished, after the change in boundary condition is propagated across this distance, you will have equilibrium. This could be done in a cycle. And so, there's a possibility of using a non-equilibrium situation to propel. I haven't done any calculations on this. It's just a concept at this stage. Vibrating cavity walls. Here's a rectangular cavity, and by the choice of the ratios of the sides, it turns out this cavity has inward force and outward force. And on this face, the force is actually 0. And this wall, if it is deflected, turns out to be at a point of unstable equilibrium. That means if you push inward on this wall, the vacuum force inward gets much greater. If it's deflected outward, there's a vacuum force wanting to push it outward more. So this is putting it out of equilibrium. But these vacuum forces could be balanced by the elastic properties of the material, a Hooke's law thing. So you could have a situation where you have vibration. You initially deflect the wall, and then as a combination of vacuum forces and Hooke's law restorative forces, you'll get a vibration. This is based on modeling of a silicon system. So a dynamic system like this might be useful in a propulsion system. Inertia control by altering vacuum energy. And we've heard a lot about this, and I'm just going to tell you kind of the current state of the art. Vacuum energy can be made negative, and one example is the parallel plate capacitor. But it does not appear possible to make an object that has a total mass of 0 or less.